Welcome back to statistics. Measures of center, like the median, and measures of spread, like the interquartile range, work together. We can use them to come up with some interesting and powerful tools for understanding the distribution of a data set. And that, of course, is one of the main goals of descriptive statistics. So in this video, I'd like to show you how this works with the median and the quartiles. We'll talk about box plots, which are a graphical summary, and the 5-number summary, which is a numerical summary. A box plot is a graphical summary of a quantitative distribution that emphasizes the middle 50%, but it also shows the data outside the middle 50%, and in fact, it identifies the outlier or outliers in the data set if there are any. The 5-number summary is a related numerical summary that consists of, you guessed it, 5 numbers, the minimum value in the data, the first quartile, the median, the third quartile, and the maximum value in the data set. I want to show you how these work by looking at an example. This is a back-to-back stem plot showing pulse rates for 19 subjects both before and after a period of intense exercise. So I want to use the distribution of pulse rates after exercise to construct a box plot. So how does that work? Well, the box plot is going to need the median and the quartiles of the data. And so I've gone ahead and calculated those here. And just did this according to the techniques we've already seen. So pretty simple to do by hand. Here's a look at the data in a dot plot. And I've gone ahead and I've marked off the quartiles. So Q1 there is 90, Q3 is 104. And I've highlighted the data between the quartiles in red. This is the middle 50% of the data, right? And of course, the length of that middle 50% is the IQR, the interquartile range. So how do we build a box plot? We begin by drawing a box from Q1 to Q3. So there it is. Then we draw a line through the median in the box. So where is the median? The median on our dot plot is at 98, so there it is. And so we just go ahead and draw a line through the box corresponding to that position. Next, we're going to use the 1.5 IQR rule to identify outliers. So let's look for high outliers first. For high outliers, we look for anything that's bigger than 1.5 IQRs above the third quartile. So 1.5 IQRs here would be 1.5 times 14, which is 21. 21 plus the third quartile, that's 104, would give me 125. So anything above 125 is a high outlier. And sure enough, we have one. There it is. We'd also want to identify low outliers. So there, I'd be looking for anything below 1.5 IQRs of the first quartile. So I'd be looking for anything below that. I'd be looking for anything that's 21 units or more below Q1, below 90. 21 from 90 gives me 69, and I have no data that's less than 69, so there's no low outliers in the data. Next, we're going to add whiskers to the box plot. This is actually a technical term. This is what they're called. The whiskers extend to the last non-outlier data on each side of the box. So on the right side of the box, for instance, the last non-outlier data are those two values at 124. So the whisker would extend from Q3 to up to 124 on the right side of the box. On the left side of the box, there are no outliers. So the last non-outlier data on the low side is just the last data point on the low side. There you see it at 96. And so our whisker on the left-hand side of the box just extends back to 96. And there we have the whiskers. Finally, the outliers, anything that's outside of those whiskers, are represented by dots that are placed in line with the whiskers. So we have one outlier, and so I raise a dot in line with that right whisker to represent that outlier at 146. And there we have our dot plot. Sorry, our box plot. So that box plot is used very often as kind of a quick and easy visual summary of the data. It shows you where the middle 50% is. It shows you where all the whiskers extend to all the non-outlier data. And then the outlier data is represented individually by dots outside the whiskers, right? The 5-number summary just sort of records the major milestones from left to right on the box plot. So the 5-number summary has the minimum data value, the first quartile, the median, the third quartile, and the maximum data value. And you see those values recorded here in this sort of tabular form for our data. So the box plot and the 5-number summary are very closely related. And it turns out they have a lot to do with the shape of the distribution, in addition to giving us this more specific quantitative information. Let me illustrate that with another example. Here's a histogram of the alcohol content for various vintages of red wine. Actually, this is California red wine. And they looked at 1,599 different bottles of wine here, all different vintages. And so there you have a histogram of the alcohol content. You can see it ranges from a low of somewhere around 8% up to a high of, looks like somewhere between 14.5% and 15%. And I'm just going to draw the box plot for this data on the same scales above the histogram. So there you see it. So notice the box plot is on the same scale. So this is all to scale. This distribution is a right skewed distribution, right? Because of the long tail going off to the right. And you see that reflected in the box plot. The long right whisker and the outliers outside the whisker are indicative of that right skew. Also, if you look at just the box itself, the right-hand side of the box, the portion between the median at 102, or sorry, at 10.2 and the third quartile at 11.1 is a little bigger than the portion between Q1 and the median. So the right half of the box is a little stretched out, and that's again an indication of the right skew of the data. This kind of thing is consistent across several different types of distributions. If you have a right skew distribution, the box tends to get stretched out towards the right. So the right side of the box may be longer, and or the right whisker may be longer. And of course, you may have outliers out beyond that whisker on the right. For a left skew distribution, the situation would flip, right? The left side of the box is typically bigger, and the left whisker is going to be longer in a left skew distribution, again indicating that long left tail. For a symmetric distribution, you won't be surprised to see that the box plot is going to be symmetric. So both halves of the box are going to be about the same size, and both whiskers will be about the same size. Another use of box plots is in comparing distributions. And this is an example of that. Here, this is, notice the box is now, these are called vertical box plots, and you see these just as often as you see sort of horizontally oriented box plots. We're looking at alcohol content in wines, but we're looking at both red and white wines. I've divided the wines into two groups, red wines and white wines. And we're looking at the box plots for alcohol content. So you can compare the alcohol content between red and white wines really easily this way. Comparing the two box plots, we see the middle 50% for both red and white is approximately the same. The middle 50% for the white wines spans a slightly larger range of percentages. but they're approximately the same. And in fact, these two distributions are, pretty close. They're not exact. You see a few more high outliers in the red data. Those are the three dots you see above, or actually, there's maybe more than three. Uh, but these two distributions are roughly the same. They're certainly similar. I wouldn't say the same, but very similar. So we can conclude that red wines and white wines in this data set are roughly similar as far as their alcohol content goes. Here's another set of side-by-side box plots, this time comparing the sulfate content in red and white wines. Sulfates or sulfites sometimes are added to wines as a preservative. And here you can see a different story. The distribution of the sulfate content is different between red and white wines. If you look at the middle 50%, for instance, it's higher in the red wine distribution than it is in the white wine distribution. You can see that both these distributions have a bit of a right skew, but the red distribution has a pronounced right skew. You see that with the outliers called out there above the upper whisker in the box. Some of those outliers are painted red by the software just to indicate that they're sort of extreme outliers. There are outliers and extreme outliers in the white distribution as well, but much less so. So we can conclude from this that the distribution of sulfate content in red and white wines is different. Red wines tend to have more sulfate than white wines, and their distribution is more spread out, right? Not only is the IQR for the red wines, which I can just see as the sort of height of the box in this vertical box plot, that IQR is a little bigger for the reds than it is for the whites. But also just the total range, especially the high outliers in the red distribution are much more prevalent than they are in the white distribution. So box plots and the 5-number summary are very useful for comparing quantitative distributions. They're useful for just describing quantitative distributions as well, and we'll be using them as tools going forward pretty regularly. So hope that you found this video helpful. We will see you again shortly with some more discussion of numerical and graphical summaries of distributions.